Okay, so let's talk about how we can use the Pythagorean theorem to help us out in a lot of different ways. So one of the ways we can do that is by examining things such as polygons on coordinate planes. So if we take a look at this example we have right here in our notes, they want us to graph triangle ABC where they give the coordinates, and I already did that. And the first thing they want is to find the lengths of all three sides of the triangle. So here's what I'm going to do. I'm going to start out finding the length of side AC. So I'm going to start with the length of AC. And to do that, I'm going to make a right triangle that uses AC as its hypotenuse. So there's my right triangle. It's green, and it involves AC as the hypotenuse. So let's do our distance formula. We know this is 1. We know this is 1, 2, 3, 4, 5, 6, 7. So I can say 1 squared plus 7 squared equals AC squared. Or 1 plus 49 equals AC squared. 50 equals AC squared. And I'm going to take the square root of both sides, and I get the square root of 50 equals AC. Now that can be simplified, but let's just leave it there for now and see what we need to do with that. So we just found one side, but it did ask us to find all three sides. So let's now find AB. Let's do the length of segment AB. So I'm going to make a right triangle dealing with AB. See, there's my right angle. This is the triangle right here that I'm talking about, this right triangle here. And I can find the length of AB using the Pythagorean theorem. We have a countable distance here, that's 2. We have a countable distance here, 1, 2, 3, 4, 5, 6. And I can say 2 squared plus 6 squared equals segment AB squared. So 4 plus 36 equals segment AB squared. Or 40 equals segment AB squared. And taking the square root of both sides, we get the square root of 40 equals AB. And again, we can simplify that, but let's just leave it like this for a minute and see what we need to do with it. The last part here is segment BC. So let's find the length of segment BC. So again, I'm going to just use my blue pen here to make a right triangle where BC is the hypotenuse. Let me show you that right triangle. It's right here. And in that right triangle, we have countable sides. 1, 2, 3, 4. That length is 5. 1, 2, 3, 4. That length is 5. And so I can say 5 squared plus 5 squared equals BC squared. Or 25 plus 25 equals BC squared. 50 equals BC squared. When you take the square root of both sides, you get the square root of 50 equals BC. Again, that can be cleaned up a little bit, but let's just leave it like that for now. Question 2 says, is this triangle scalene, isosceles, or equilateral? Well, remember, we're talking about the white triangle. The white triangle here is our original triangle. And eyeballing it, well, it's kind of hard to see. It's pretty hard to say if it's scalene or obtuse or isosceles. That's why having these lengths is really helpful. I can tell that this is isosceles. And the reason I know it's isosceles is because segment AC is equal to segment BC. They both have a length of radical 50. Question 3, find the perimeter of this triangle. Well, the perimeter is just the sum of the sides. So it's radical 50 plus radical 50 plus radical 40. And we're going to have to go right to our calculator to figure that out. So in my calculator, what I'm going to type here is I'm going to type right here in my calculator the square root of 50, and I'm going to arrow out, plus the square root of 50 again, and I'm going to arrow out, plus the square root of 40. And that says that the perimeter is about, so I'll make these wavy equals, 20.47 units. Not units squared, it's not area, it's just units. And the last question is this a right triangle? How do we know? Well, we know right triangles have right angles. And the way I'm going to check to see if this is a right triangle is I'm going to look at the slopes. If I have right angles, I know I'm going to have opposite reciprocal slopes. So let's check the slopes of each of these segments. I know the slope of segment AC is, well, look up here. AC was this green triangle. And I have the slope triangle already drawn. The rise is 7, the run is 1. So that's a slope of 7. Now, if I do have a line perpendicular to this, I would expect to see a line that had a slope of negative 1/7. Let's keep going. AB, line AB is the red one. And again, the slope triangle is already drawn. The slope here going from B to A is a rise of 2 and a run of 6. And that reduces down to 1/3. So these are not opposite reciprocals. So that would mean this angle right here is not a right angle, the angle between the green and the red. So we have one more left. Let's check the slope of BC. Again, slope triangle is already drawn. Going from B to C, my rise is down 5. My run is right 5. That's a slope of negative 1. Since none of these slopes are opposite reciprocals, no, it is not a right triangle based on the slopes of the sides. So there's our little activity today, and all we're doing is we're using the distance on a coordinate plane through the Pythagorean theorem, and we're just expanding it a little bit. So tonight your homework is the back side. You have a couple problems there to play around with. Play around and see how you do.